Hi. So the whole purpose of the Breakthrough Junior Challenge is not only explaining the existing fundamental laws and theories of physics and mathematics, but also trying to look at them in a completely different way. What I want to talk about today is dark energy and alternative explanations to it. When Edwin Hubble discovered that the further the galaxy was, the faster it was moving away from us because of its increased redshift. It meant that the forces opposing gravity were much larger, thus the universe was expanding. There is a principle known as Pauli's exclusion principle, which states that particles of spin 0.5 or fermions which make up matter cannot exist in the same quantum state, which basically means that they cannot have the same position and velocity. This results in electron degeneracy pressure, and it explains why matter doesn't collapse to a state of very high density. This can be applied to the whole universe as well. The amount of matter density needed for the forces to be large enough so that they just oppose gravity is known as critical density. Specifically, it is the average density of matter required just to halt the universe's expansion so that it comes at a static state, like Einstein thought it did. The problem arises when you calculate the combined mass of all the observable mass in the universe and see that it is much less than the critical density. According to these observations, the universe in fact should be contracting. This is where dark energy and dark matter come into play. The acceleration of the universe is a function of dark energy density, which is constant throughout the universe. Observations of the cosmic microwave background reveal that the universe is flat, as the brightest microwave background fluctuations were about 1 degree across. In order for the universe to be flat, the ratio of the total density of the universe to the critical density should be equal to 1. Since observations suggest that the density in matter is significantly less than the critical density, there should be some hidden density. It has now been accurately measured that the density of baryonic matter accounts for 5% that of the critical density, while dark energy and dark matter account for 68 and 28% respectively. Okay, so now the need for dark energy is to account for the energy density that opposes gravity so much that the expansion of the universe is possible, while dark matter accounts for the missing mass density. Here's an idea. What if the accelerating universe is just an illusion? Rather, it is just slowing down as one would expect from what we know about gravity. The false impression results from the way our particular region of the cosmos is drifting throughout the rest of space. Our relative motion makes it look like the universe is expanding faster and faster, while in actuality, its expansion is slowing down. It's rather like boating in a river. If you move upstream, your speed would be much slower, but if you're going with the stream, your speed increases. According to Hubble's law, the universe should be expanding uniformly, but there was a first anomaly first recorded in 1973. It's called the Great Attractor, and it resides in the Hydra Centaurus supercluster. According to standard cosmological models, the motion of galaxy clusters with respect to the cosmic microwave background should be randomly distributed in all directions. However, after analyzing the WMAP, it was found that there was an unexplained velocity of galaxy clusters towards the Great Attractor. This unexplained velocity is known as dark flow. Now, observers residing inside the dark flow could falsely conclude that the universe is expanding. Dark flow would cause the space-time within our moving boat to expand faster than the space-time outside of it. According to Einstein's explanations of gravity, the heavier the object is, the more curvature it brings about in space-time fabric, so more the gravity it possesses. Knowing that light we observe from nearby galaxies in the dark flow left its source more recently than light from galaxies further away which are outside the dark flow, we get the false impression that the universe is accelerating because of the difference in space-time curvature of the two makes it appear that the galaxies have a larger redshift, while in reality that increased redshift is caused by the distortion in space-time. This phenomenon is called redshift space distortions. More support comes to this theory when, while analyzing the cosmic microwave background, it was found that the universe seemed to be stretching in one way more than the other. This left scientists puzzled, but the dark flow explains this phenomenon quite well. Observers would measure slightly faster acceleration in one direction than the other. So, it is important to note that this alternative explanation might not be necessarily true, but the same goes for our current understanding of dark energy. Thank you.